Okay, for a Cartesian coordinate system, the vector components of vector A are ax times vector I plus ay times vector j plus az times vector k. Of the vector A with the components ax, ay, az, they are the vector components of A onto the unit vectors I, j, and k. So meaning the vector projection of A onto I is ax times I, right there. The vector projection of A onto J is ay j. And then the vector projection of A onto K is az k. Okay, so given vector v with head at -4, 1, vector u with head at 4, 3, determine projection of vector v onto vector u and illustrate in a diagram. So, sorry, should be vector projection. Okay, so remember, these are position vectors. So where are their tails located? For position vectors at the origin, yeah. So -4, 1. This is vector v. And then 4, 3 is my vector u. So we want to figure out the vector projection of v onto u. So imagine if you were to extend vector u a bit, like so. And then you want the horizontal component of vector v onto vector u, and it has to point, in this case, in the opposite direction of vector u. Because you can see from the diagram, between vectors v and u, the angle theta is obtuse. Okay. So, vector projection v onto u. So that's equal to v dot product with u over u dot product with itself times vector u. So that's going to be -4, 1 dot product with 4, 3. And then over 4, 3 dot product with itself, which is the same thing as calculating the magnitude of u. So if you would prefer to do that, or u squared, you can do that. Okay. Dot product x1 times x2 plus y1 times y2. So it's going to be -16 plus 3 over 16 plus 9. As a scalar multiple of vector u. So what does this become? What's the answer? -13 over 25 vector u. So remember, this is a scalar multiple of vector u, and the scalar quantity that you're multiplying is -13 over 25. Okay, so that's -13 over 25 of the components 4, 3, which is going to be approximately equal to, so give me a couple of decimal points so that we can estimate where we need to stop drawing the vector projection. So calculate -13 over 25 times 4, and then -13 over 25 times 3. One decimal place, two decimal place.
2.1.
Negative 2.1 and
Negative 1.6.
negative 1.6. Thank you. So that is going to be negative 2.1, negative 1.6, right around here. So this in blue is our vector projection of V onto U. Any questions? All right, take a few minutes to try example 5 on your own, and then we'll take it up afterwards.